research is questioning and disagreeing. I'm Mayla Boguslav, and I study research. I ask questions such as, what is research? How do we measure its success? I live by the motto, ignorance is bliss, because when you don't know something, it's an opportunity to learn. Researchers live in the ignorance or the unknowns. They ask questions, identify areas of ignorance, lead the way to gain knowledge, and most importantly, ask the next questions about our new ignorances. Welcome to the Ignorance Podcast, where we learn about research through research questions. Let's welcome our guest researcher for today. Please introduce yourself by name only and your favorite thing to do outside of work.
Hi, I'm Teri Hernandez, and my favorite thing to do outside of work is either go running or hiking.
Interesting. What do you love about running and hiking? How does it kind of get you out of work?
I think it actually helps me not think about work. It's the only time I really have for myself. So I think about other things.
It's always good to have other things to do outside of work, right? And not just focus on the science. And on top of that, right, our science gets to meld in our head, right, when we're kind of doing those things too. So what questions excite you in your work? What questions are you currently pursuing?
The current questions that we're pursuing are, number one, like what is the impact of timing of lipid exposure during the gestational period, meaning various gestational weeks, early in pregnancy versus mid-pregnancy versus later pregnancy. And the reason that's relevant is because fetal growth is different at each of those, in each trimester of pregnancy. The second question, or the second set of questions that I'm currently pursuing, are to identify a safe range of carbohydrate intake for pregnant women in terms of its impact on fetal brain development. And the reason that is relevant is because many populations are just sort of drifting toward a lower carbohydrate intake across on a population level. But secondly, there's a lot of messaging to people, including pregnant women, about ketogenic diets, low carb diets, and we really don't know what's safe in pregnancy, believe it or not.
Yeah, can you speak a little bit more about what is a lipid and what are carbohydrates?
Sure. So, well, there's several lipid species, and the one that we tend to focus on in pregnancy in the context of fetal growth is the triglyceride.
Okay.
So if you have that measured at your doctor's office as part of your cardiovascular panel, it is part of it. And so the reason that triglycerides are the main lipid of interest is because it's the most sensitive to diet intake. They all are, but your triglycerides are, dependent on your meal, and they're very, they fluctuate throughout the day based on that. And then a carbohydrate is mostly intakes of sugar and grains in your diet, and we study that in the form of glucose or blood sugar.
Gotcha. And a triglyceride is a fat, correct?
That's correct.
So these are important questions, right? If we don't know what we should be eating in pregnancy, right, which in some level is kind of your goal, whether that's triglycerides or carbohydrates, and even not just pregnancy at large, but what time points of pregnancy, how do we know what we should be eating, right? With all these diets out there, you're trying to ask these questions about what we should be eating at different time points, specifically to influence the fetus, right, in those ways during gestation.
That's correct.
Yeah, really fascinating question. So with that, how do you hope to impact the world?
The dream would be to have influenced recommendations for nutrition, not only in diabetes in pregnancy, but for all women, for all pregnant persons across the globe. And so I would say I've made a small dent, but I have a lot more work to do. And really what that would look like is having, actual evidence-based information for women to consider in terms of ranges of what they can eat, what are good eating options in terms of diet pattern, and importantly in ways that it fits into their lives and they're not left with just prescriptive information that doesn't fit their cultural diet pattern or allow them to eat with their families.
Can you say more about what you've already done in terms of those recommendations, and also what makes it so hard to get those recommendations and get that evidence base?
Yes, historically there were very strict limitations on studies in pregnancy because of the fetus. And not only that, but before 1994, women weren't represented well in research because there were federal regulations that also restricted their participation in clinical trials. So really any information that we have is very recent, only really in the last 2 decades or so, other than what's based on clinical observation. But we didn't have the level of evidence that we need in pregnancy in terms of rigorous randomized trials or even rigorous cohort study designs, which actually can be very informative. Those are some of the limitations, previously. My work with my colleagues is we conduct very controlled studies of nutrition and metabolism in pregnancy. And so what I mean by controlled is that if we want to study a diet, often we will provide it to the women so that we know what they're eating, right? Because one of the biggest limitations of nutrition research is that you don't really know what people are eating. And even though our model isn't perfect, that's been our approach. And we also do, kind of controlled studies in the clinic setting and in the hospital. And so historically, meaning over the last 20 years or so, that has really allowed us to perform what we call deep phenotyping work. So as part of that work, we have performed several studies now, many studies that involve nutrition in pregnancy. One of the larger studies was a randomized control trial of a low carbohydrate diet versus a more liberal carbohydrate diet, which has more complex carbohydrates in gestational diabetes. And then the triglyceride work really grew from those studies and also several kind of larger longitudinal studies. And by longitudinal, that doesn't mean years. We mean longitudinal within the pregnancy and within the gestational period. And in those models, we've also studied the placenta. We've studied fetal growth, during gestation and then after delivery up to a year of life.
What have been the recommendations that you've been able to say from that? Can you talk a little bit about your results from that study that you got to do? That is kind of really groundbreaking compared to what people have been able to do previously.
Sure. Gestational diabetes is the most common diabetes phenotype in pregnancy currently. And what I mean is that it's different from what we call pre-existing diabetes, where somebody starts the pregnancy and we already know that their pancreas doesn't produce insulin, so they have type 1 diabetes. Or another form of pre-existing diabetes is type 2 diabetes. And so people come into the pregnancy and typically know that they have one of those diabetes. Gestational diabetes is diagnosed late in the second trimester. One other important thing about gestational diabetes is that the primary therapy is nutrition. So no matter where in the world a woman is who receives a diagnosis of GDM, gestational diabetes, no matter what the criteria are, they're all recommended nutrition to start with, right? And often that will treat the diabetes in terms of gestational diabetes. Historically, because women couldn't be in research, for a number of reasons, really the nutrition recommendation was informed by our experience in people with type 1 diabetes. And that goes way back, believe it or not, to before insulin was discovered in 1923 by Banting and Best. And so it turns out that before insulin, if you can imagine this, we had no insulin, right? The only way to keep someone alive with type 1 diabetes was by not eating carbohydrate or eating very little of it. So the pre-insulin diet for those individuals was about 8% carbohydrate, 85% fat, and the rest protein. So very high fat, very low carbohydrate, because that's how we kept them alive. And also they used to constrict calories. So literally, these people were not only starving, but they were miserable. And so, insulin really changed that.
Doesn't sound
But
fun.
yeah, I mean, it's actually a fascinating history. And so those recommendations for a low carb diet, I mean, that's kind of, we learned from that. And even when insulin was invented, and we've, been able to enhance insulin tremendously over the decades, really that low carbohydrate diet pattern in terms of a treatment strategy has remained. And by the way, it does have merit, for reasons that we could talk about. The gestational diabetes phenotype started to emerge in terms of population health in probably the late 1950s and the 1960s. So at that time, the low carb diet made a lot of sense, and it still does in some ways, right? The question now is what does low carb mean? And again, we don't know how low we can go. We don't know safe thresholds in pregnancy. And so I think what you asked me is, well, what did we discover? So when, originally when I was a doctoral student a long time ago, before I was a doctoral student, I was a cardiac nurse. And so, I love cardiac care. Like that is my, I actually was not an obstetric nurse by training. I'm a cardiac nurse by training. And so I spent a lot of time with people with cardiovascular disease and their families. And I took care of very sick men and women for a number of years. And one of the things that came with that was a couple of observations. Number one, I usually injected their insulin. So there was this coexisting issue, right, with cardiovascular disease and diabetes. And number two, I saw their eating patterns. And their eating patterns were often characterized by, very high fat diets, poor diet pattern in terms of processed foods, and so some of those things. And so fast forward when I was a doctoral student and started working with pregnant women, particularly with gestational diabetes, as their nurse, because I was with them in kind of the context of some of our other research studies. So they talked to me about what was on their mind, and they were really stressed out about the diet. And in fact, they hated the diet. And they described their eating patterns, and over time, it wasn't just one person. I saw a theme over a couple of years. And what I saw was that they were so afraid of having a large baby, which is one of the things we worry about in gestational diabetes, as a reflection of maternal high glucose, high blood sugar. They were so afraid of that they figured, well, I'm not going to eat carbs. And so they were replacing those calories with fat.
There's the connection.
Yeah, so I had made a connection with my clinical experience at that time, still. And I really questioned, I was very concerned why they were eating that way. Number one, and then number two, I kept thinking, okay, this is a known population. Like we know that women who have a pregnancy complication, like diabetes, like gestational diabetes, like preeclampsia, we know that that's a risk factor for cardiovascular disease and later diabetes. Why are they eating this way? So it turns out that there wasn't good evidence really to support the low carb diet in gestational diabetes. Okay. And so what we found in a randomized trial in a rigorous manner is that actually when we randomized women to kind of the historical low carb diet versus one that we call choice, choosing healthy options in carbohydrate energy, the idea is that people can eat carbohydrates, but choose the right ones, right? And so what we found is that in the terms of the two diets, there wasn't a difference in fetal growth. And in fact, the babies were not born too big in the choice diet. And what we also found, amazingly, actually, is that both diets controlled maternal blood sugar nicely to our conventional kind of therapy targets that we have right now. And so what we think it means right now, I have more work to do in this area, is that it seems like we have identified a range, and we provided all the food, and this was all carefully done. But it looks like a range of 40 to 60% carbohydrate is actually safe in terms of fetal growth for gestational diabetes. And there's tons of other data, and I know that was a little bit of a long story, but that is what we found, and it really defies what we thought we knew about gestational diabetes and diet pattern.
Right, so this gets at one of my other favorite questions to ask of what has been your most surprising result? Is that kind of your most surprising result, or do you have another one that you'd like to share?
It's actually not. The most surprising result was actually not the glucose or the blood sugar patterns, but we also did some controlled breakfast studies where, as part of this, we know what they're eating. We had women come into the clinic. We gave them a known breakfast meal, kind of a large meal for that matter. They stayed with us in the clinic for 5 hours, and we drew their blood every hour so that we could measure other things than just glucose. And one of those things is called a free fatty acid, and it's a breakdown fat from a triglyceride. So we also measured the triglycerides. But what we saw is that even though the glucoses on both diets were well controlled, only in the low carb, high fat diet did we see a higher pattern of postprandial free fatty acids. And so it's an unknown exposure. We can't measure free fatty acids out in the community. Women can test their blood sugar. We have great glucometers. We actually have a triglyceride meter now, so we're using that in some of our other work. But the free fatty acid finding was a big surprise. I'm glad we measured it. I wouldn't have even known to hypothesize that per se, because again, it was a surprise finding, and we have since replicated it in another cohort in a bigger study. So that was probably the most surprising. And by the way, and second, this is a little bit crazy, but we also sampled adipose tissue in the women in the early work.
So like the fat tissue.
Some fat tissue. Yep. Thank you. And, we take the tissue back to the lab, and we can do some experiments kind of in petri dishes, right? And what we saw was kind of the same, the free fatty acids that were high after the meals. We saw like how the fat tissue behaved in the same manner in the dishes when we exposed the fat cells to different, insulin and some different hormones. So it's several pieces of information really that kind of form a picture of what's going on, and that was also kind of a surprise.
Yes, okay, I guess so. This is true in general with surprises, right? When we find a surprising result, we want to dig into it because it's really unexpected, right? We don't think it may be even true, and so we want to target it from lots of different angles to understand, does it really make sense, right? Is it real? And so, as you said, right, you did a number of different experiments to be able to get at kind of this answer of what's really going on. And obviously, it sounds like there's more to explore. But can you just speak a little bit about what does this finding mean?
I would love to. Thank you for asking. So the free fatty acid piece here, the story that I'm telling you about, is important for a couple of reasons. First of all, when we consider mother, that higher free fatty acid exposure to the blood vessels, to the tissues, can actually diminish insulin's ability to work well.
Okay.
So it causes what we call insulin resistance, and you may hear that, when you're hearing about people with type 2 diabetes and different, but essentially what it means is that your insulin doesn't work very well in the vessel walls, in the tissue, where the receptors are. So the high free fatty acids can have that implication for mother that actually makes their insulin work less well, and that causes more fuels to go to baby, right? The second thing, there are impacts on the placenta, but I think we know a little less about that at this point, is the baby. So the fetus really relies on mother's blood sugar very highly in terms of its overall growth and particularly for its brain. The human newborn has the largest brain of any species. And so, there's evolutionary context for that, as we can all imagine, right? So maternal blood sugar that informs that glucose exposure is important. We've also learned, however, that maternal triglycerides and how they get to this free fatty acid, that's another growth fuel for fetal overgrowth. So what we're seeing in maternal diabetes, and even outside of diabetes, so that's why this is so important, is lots of babies that are growing too big. And and that's not necessarily an inherently bad thing. Some of it's genetic, a lot of it is not. And when it's not genetic, and there's an overgrowth pattern, it's actually a risk factor for later metabolic disease, later pediatric obesity. And so the free fatty acids, just to kind of bring that all together, have important implications for mother's metabolic health and also the baby's growth, particularly in terms of overgrowth, right? And so the idea is, if you go back to really any pregnancy diet, but specifically diabetes, because we know more about it, if mother's glucose and her blood sugars look great, there could be these other exposures going on from nutrition, and we're not measuring them.
Thank you. Yes. So I guess the other side of this coin is, what is one of your favorite disagreements? So we have surprising results, right, that can help us go down new paths. But other ways that we come up with new ideas or really sharpen our ideas is through disagreements. And so do you have a favorite disagreement that you've had throughout your years of research?
The low carb saga is probably one of the biggest ones. And as you can imagine, when I was in my early career and started challenging the low carb diet for gestational diabetes, the 100-year histories of that, I was pretty much on the blacklist. The good thing is, now that we have some evidence, to support, kind of both ways, it's actually pretty fun to be able to debate this. I'm thinking of others that there are several controversies in diabetes in pregnancy. The big one now is, it's called early GDM, which is a new diabetes phenotype that is, I'll say, emerging, but it was there, but we weren't picking it up before. That is one of the controversial topics in the field, open for debate. And it's so fun to talk about it, but often I find myself just sitting here listening to the different sides go back and forth, because the evidence is emerging and we have incomplete information on that phenotype and what it means, and should we treat it and how we treat it.
So can you, for me, define a phenotype?
Yeah. A phenotype, by definition, goes back to your genetics, right? And how your traits are observable by others, right? And so that might be your eye color is part of your phenotype, your skin color, of course. Anyway, we could go on and on. But we also think of phenotype in terms of metabolically, kind of the metabolic milieu. And that's what I'm referring to in this case, because gestational diabetes is kind of links back to blood sugar and your metabolism. And so it is a phenotype in that way, right? But undeniably, there is a genetic underpinning, right, somehow. So that's how it's still, it is a phenotype. But you're right, we need to qualify which kind of phenotype we're really referring to in the context. So that's what I'm talking about, is metabolic phenotypes.
Yeah, thank you for that definition. Yeah. And to go back to this disagreement, it seems like there's new definitions arising, right? And new data coming out that's showing new patterns that we didn't know existed before, even if maybe they did exist before, right? We just weren't able to measure them, right? So this idea of new methodologies, new ways to do things is also how science moves forward. We create new innovative ways, we come up with new questions that allow us to learn new things, right? Kind of explore the space of the ignorance, and that leads us down new paths that we had no idea really existed before. And so who has influenced you? Who are people you look up to? There's the people before you, there's the people after you, and all of it is a crosstalk between all of this. And all the questions that have been asked before, we can continue to ask and also change them and ask new ones as we go forward.
Sure, I've been really blessed with having excellent mentors, and they don't all work in pregnancy. One of my most important mentors, his name is Dr. Robert Eckel, and he's an endocrinologist. Now he's retired, but of course he still works because he loves the science so much. He not only trained me in metabolism and helped me understand the link between cardiovascular disease and diabetes, which is insulin resistance, one of the primary connections. He not only helped me understand that in terms of science and rigor and approach, but he also trained me in terms of like kind of the parts of science that like you don't get from working with experiments. Things like how to ask the question. All of us that came out of Bob's lab, we know the Eckel rules, we call it. Like every good question leads to 3 more. And Mayla, I think you and I talked about that, yeah, when you were a graduate student. The second thing that he taught me about science in particular is let the evidence speak for itself. Leave my bias and my belief at the door and really listen to the numbers, listen to the pictures that numbers form, which, we make graphics. And then another lesson he taught me was to find a niche. So when I came into this, I wanted to solve nutrition for all of diabetes. Like I was going to, well, it turns out there's like thousands of scientists working in that. And I haven't given up on some of those questions. However, it turns out that pregnancy, which is like the most fascinating example of insulin resistance, almost none of the work from general diabetes has been conducted in pregnancy. So it's very much a black box. And so Bob was right. So Bob, yeah, he's one of my most important mentors. One of my other most important mentors was my primary mentor when I was a doctoral student. We still work together today. Her name is Linda Barbour. She's also an endocrinologist, but she specializes in endocrinology of pregnancy and the disorders and some of the variations that are seen there. Early on, I had to convince her of, some of these questions, but ever since I did, we've stayed together, and really she's been one of the most important mentors of my life in terms of science and, and we know each other in our lives too. So those are 2 really important influences on my career.
Yeah, I love the Bob Eckel rules. I think that's so fun because in graduate school we don't learn necessarily kind of the skills of how to really be a scientist once you kind of leave the lab, right? We learn a lot of experimental approaches, and that feels maybe you could take it from a class. But in terms of all the other stuff, right, it's much harder to learn those, and it's much more of an apprenticeship, as I kind of felt in my graduate studies, where you're learning from these experts. And a lot of what I want to do in this podcast, right, is kind of showcase how do we actually do that, right? How do people come up with these questions? How do they end up where they are? So the people matter, right? The people in terms of both how they taught you, what lessons you got both from the experimental ideas, but also just at large in life, as you were saying, with both your mentors. And it's just really important to acknowledge all of those people that came before us, right, and really influenced us. And you're also somebody who influences lots of students too, right? You are one of my advisors for my PhD, and I really appreciated how much you think about the question and help me think about my own questions with regards to research. So I'll say thank you here as well for how you both had those mentors and pass it down the line as well, which is always really, really great. And so kind of my last big question, actually maybe I have 2. How do you know you've been successful at your work and as a scientist? What is your evaluation criteria?
I can think about that question on different levels, right? Because as we all know, you publish your reports and so many stories never make it into the reports, right? The science that I conduct is a relational human science, right? I'm a nurse. I listen to people. That's really where a lot of the questions I ask come from, is because I try to be their voice, right, in the scientific community. So part of how I know if we've been successful is, through those relationships, that they've had a good experience in, taking part in the science. Because people who, human subjects and human participants in research studies are very special people who really, it's okay if you go into it because you might get paid a little bit, or that, they have different reasons for going in. Largely, they want to give back. Mm-hmm. And so I feel like that's one metric of success. If I can look back over my career and the hundreds of people, not all pregnant women, but many are, and I think about, their experience and that I was able to partner with them, that's definitely a metric of success. Another metric of success that maybe is less well considered is, the idea of the question itself, right? It's like you ask the question and then you have to bring the question to life. And how does that happen? It's through designing the experiments and working with your colleagues and all the energizing conversations. And suddenly it's not just a question, right? I mean, it truly is. It takes on a life of its own. And there's something about going through the process, and no matter what the result is, because remember, we have to be ready. We have to be ready to be wrong. Or maybe we're right no matter what, right? Because if we're listening to the evidence, I guess another metric of success is no matter the outcome, if you've really gone through the scientific method in a rigorous way, you haven't fooled yourself, not my words, but Richard Feynman, right, said that in 1974. I think that's a success. You're listening and you're willing to tell their story.
And you bring the question to life. The process is really fun, right? That's why I do what I do in terms of studying researchers, and I love bringing researchers' questions to life. My last question for you, and I'd love for you to think big, is if you could do anything, not limited by grants or other factors in your space, what would you be doing? What is your vision for the world?
That is a big one. The dream for me would be to have a role where I am a dean of a school of nursing, and really working with nurses and, of course, our interdisciplinary colleagues to help influence human health for all people, across the globe. But as part of that, to also maintain my science career, the largest cohort study in pregnancy across the globe happened in the early 2000s, and it included about 25,000 pregnant women. I mean, we're still learning from those data today. I would love to be part of a team that leads a study that large to really identify nutrition, safe nutrition, and really look at questions of nutrition globally for all pregnant women. And part of that would be about economics, because I'm not sure how well known this is, but pregnant women and young girls are actually priced out of good nutrition globally. I mean, it's a call to action for the field. But I recognize that I love doing controlled science with smaller samples, and we do the deep phenotype. I love that. However, on the counterpoint to that is we do need larger numbers to really be able to look at some of these questions. And nutrition is such a critical driver of population health and fetal development. If we had a cohort that size, and actually we have the network, I really think we could move the field forward. And not only the field, but human health. So actually now that I've said it, I need to bring the question to life, don't I?
I was just going to say, I challenge you to do it, and I hope that maybe the next time I have you on this podcast, that you are starting to make progress towards that goal, right? So I guess what I'd love for you to do now is introduce yourself, where feel free to say your job title and your field, and any other information you'd like to say.
No, thank you. I'm Teri Hernandez. Thank you very much for having me. I'm at the University of Colorado at the Anschutz Medical Campus, and this is my 25th year on campus. I'm a professor of nursing, and I'm a pediatric nurse scientist at Children's Hospital Colorado. And I am the Associate Dean for Research in our College of Nursing. And it's a very special role for me to be able to have all of those different things. And so, anyway, those are a few of the hats that I wear here in Colorado.
Yeah, thank you. And I'll just also add that Teri, as I said, was on my thesis committee. I always appreciated you looking really deeply into the knowledge and the questions I always brought, and really being my expert in prenatal nutrition, which is the field of my topic I really focused on, and really being excited about all the questions I brought to you. That a piece that I always loved whenever I would come into your office and talk about things is I actually would leave with 3 more questions, and not only 3 more questions, I would leave excited about all these questions and really like see the next things. And even this idea that you're now really studying the brain is really exciting to me, because that was one of our findings that we found in my thesis, which was very cool, and how much the brain is really impacted by a lot of these things. And so I'll also say thank you, Teri, for doing this podcast with me. And your science is so cool. And I think you'll really have that impact that you want to have at the end of the day. So thank you, Teri, for all that you do for the scientific world, and for me especially too.
Mayla, thank you.
Teri wants to solve nutrition for all of diabetes. She found her niche of pregnancy and asks questions leading to groundbreaking research and new recommendations. My biggest takeaway is the Eckel rules. Every good question leads to 3 more. Let the evidence speak for itself, and find a niche. What 3 new questions do you have for me or my guests so far? Post a comment on YouTube or let me know on Blue Sky. This podcast is hosted by me, Mayla Boguslav, and produced and edited by Joshua Mendel. To learn more about this episode's guest and any cited or named people, take a look at the episode description. Thank you for listening to this episode of the Ignorance Podcast. Please follow the Ignorance Podcast wherever you get your podcasts to learn about science through research questions.